Ever wondered how AI can predict heart disease from a single scan or decode genetic mutations in seconds? Today, we're diving deep into the cutting-edge research, transforming healthcare through machine learning. This isn't just about algorithms, it's about rewriting the rules of medicine. Let's break it down. Let's start with the basics. At the core of modern AI is the neural network, a computational model inspired by the human brain. These networks process data through layers of interconnected nodes, each applying mathematical transformations to extract patterns. But here's the kicker, they need massive datasets to learn. In healthcare, that means millions of medical images, genomic sequences, or patient records. The challenge? Ensuring data quality. Noise, missing values, or biased samples can derail even the most sophisticated models. Researchers tackle this with techniques like data augmentation, synthesizing new examples from existing data, and federated learning, which trains models across decentralized datasets without exposing sensitive information. But raw data isn't enough. How do we translate this into actionable medical insights? Enter the transformer architecture, a breakthrough that's revolutionized natural language processing. Originally designed for text, transformers now analyze medical scans by treating images as sequences of pixels. Their self-attention mechanism lets them weigh the importance of different regions, like focusing on a tumor's edges in an MRI. Meanwhile, generative models like GANs, generative adversarial networks, create synthetic patient data to train algorithms without compromising privacy. For example, a GAN can generate a realistic CT scan of a lung with pneumonia, expanding training sets while keeping real patient data secure. Yet even the best models face a critical hurdle, interpretability. Can we trust an AI's diagnosis if we don't understand its reasoning? This is where explainable AI, XAI, steps in. Techniques like Grad-CAM highlight the regions of an image a model focuses on, giving doctors visual confidence in its decisions. For instance, if an AI flags a suspicious mole, Grad-CAM might overlay a heat map showing it's analyzing the border irregularities, a known indicator of melanoma. Meanwhile, SHAP, happily additive explanations, breaks down how each data point contributes to a prediction, revealing if a model is unfairly weighting a patient's age over clinical symptoms. These tools aren't just for transparency, they're essential for clinical adoption. Now let's talk about real-world impact. How is this technology already saving lives? Take Google Health's AI for breast cancer detection. Trained on 29,000 mammograms, their model outperformed 6 radiologists in identifying tumors, reducing false negatives by 5.7% and false positives by 9.4%. Or consider DeepMind's AlphaFold, which solved the 50-year-old protein folding problem. By predicting how amino acid sequences fold into 3D structures, AlphaFold accelerated drug discovery for diseases like Alzheimer's. And in genomics, tools like DeepVariant use deep learning to call genetic variants with 99% accuracy, enabling personalized treatments tailored to a patient's DNA. But with great power comes great responsibility. What ethical challenges arise here? AI isn't neutral. If a model is trained predominantly on data from one demographic, it may fail for others. For example, a skin cancer detector biased toward lighter skin tones could miss early signs in darker-skinned patients. To combat this, researchers are developing fairness-aware algorithms that audit for bias during training. There's also the issue of accountability. If an AI misdiagnoses a patient, who's responsible? Regulations like the EU's AI Act aim to classify medical AI as high risk, requiring rigorous testing and human oversight. The goal isn't to replace doctors, but to empower them with smarter tools. AI in healthcare isn't a distant future, it's here, evolving rapidly. But its potential hinges on collaboration, data scientists, clinicians, and ethicists working together. If you're inspired by this journey, hit subscribe for more deep dives into AI's frontier. And drop your questions below. What breakthroughs excite you most? Let's keep the conversation going. Thanks for watching. Remember, the next medical revolution isn't just in labs, it's in the code. See you next time.